So when working with data, our work is often guided by three distinct systems. We track our code changes using Git. Then we also have to track our materialization changes due to our code changes. And then we often also want to create a new environment to test our code changes, for example, so that we don't interfere with the production data. Imagine all of these three systems are now merged into one. And that is what Virtual Data Builds does in Y42. It is a new concept that combines code changes, materialization changes, and operational changes tracked in one system, which is managed exclusively through your known Git workflows. So next I will walk you through a demo in our platform and show you all the benefits we have through Virtual Data Builds. And I will also show you how Y42's data pool, the internal data schema, is looking like. So here I am in Y42's platform, and in the last video I already walked you through our app and showed you how we can set up and orchestrate an entire data pipeline in here. However, in this video we want to dig a little bit deeper and we want to look at all the possibilities that Virtual Data Builds brings us when we develop our data pipeline. Before we start with that, we need to load some data into our data warehouse. So I'm adding here a source folder where we can import a new source. And I want to import a BigQuery dataset of some shop data. And here you can see I can just select a connection that I already did. So I did the authentication part already. And so I have the three tables already here and can simply select them. As always in Y42, the changes that we made through the UI are reflected in our code as well. So here's the new source config with the integration already set up. And we want to commit and push the changes that we made to the code base here. Now we only need to write a git commit message. I'm writing edit sample shop data here. And then we can commit it. And you can see on the top that it's also automatically pushed to the remote repository. On the right side of the screen, I now opened the lineage mode where we can view our asset. So here you can see the shop asset that we created with the three tables. And yeah, it has never been materialized. That is why we don't have any builds from before yet. On the left-hand side, there's our data warehouse with two datasets. This dataset here reflects our main branch, and it is currently empty because we have never built something. So here you see it is called main, and we are also on the main branch. The dataset on top of that is our data pool, where all of our tables are actually created, while the data in the main dataset would only point to the data from our data pool. But let's just try it out and trigger our first build, and we will select a full import for that. So we have now successfully triggered a job, and you can see here that it's queued at the moment. So we have to wait till the data is actually imported. So you can see here that the build was successful, and now also the columns were loaded. So let's view how it looks like in our data warehouse. For that, I need to quickly reload BigQuery to view the data. And here you can see that when we click on the internal schema, a newly created table is loaded in here. And even if the table name is a little bit weird, we see that it's the same table because of the columns. So let's just check. Yeah, these are the same columns. So it must be our table, but why is this such a weird table name? It is because we are only looking at the internal table, while the actual view on the table is stored in our main view. But why do we actually need this referencing of internal tables and so on? Let me expand our project so that we can see the benefits of Virtual Data Builds. I've now also materialized the other two tables in the source and added the MART users model, which is a basic DBT model, and I combined the three source tables for that with a join, and I also materialized the table already. So let's check it out in the data warehouse. Our internal schema now has three additions, two other tables and one other view. The free tables represent our free source tables, while the view represents our mod users table that points to our free tables, so it actually just combines the free tables through the join. However, as a user, you don't want to look into the internal schema, but you are interested in the public-facing views. And also here again, we only point to our internal schema, so we aren't creating any duplicate data here. What happens now when we would add a column here? So let's add this column language, and we will write a good commit message for that. We say, okay, we added a column language here in the mod users table, and we commit and push the changes again, so that Y42 actually detects, hey, the code that we just created, it's not representative of our actual data. That is why the model is marked as stale here. In order to update our data to our code again, we need to build it again, and that is what I did here, so that our table is not stale anymore, but that it can turn into the green color of a successful build again. What happens in our internal schema as a result is that there is a new view created, and of course it has the language column added, and this is now the new origin of our mod users model. But why do we then have this old view still existing in our data warehouse? It is because Y42 not only version controls your code, but also your data. So every table name that you see above is actually a code representative to our materialization logic of our assets that we got through a smart hashing system. Because we are version controlling your data, you can not only roll back code changes, but we could also reconstruct our data. So here was the column that we added, and now let's press on revert file changes. Now you see the column is deleted again, and we made an automatic commit here, and in the code the column is not here anymore, and because we committed it, Y42 detected that our logic is now different, so the mod users view simply points to the old view again without the language column. And this is possible even without rebuilding this asset. Now imagine our mod users table is consumed by a dashboard. The dashboard must be accurate, so we need to be careful when we want to change something in this mod users table. Normally, you would need to set up an entirely new environment in a different data set by copying the whole data and also setting all the configurations and code up in another environment again. In Y42, you can simply create a new Git branch, which is equivalent to a new virtual environment. We call it virtual environment because we don't actually have to clone any data or any code. We're using what we already have, but it still feels like a completely separate project where you can develop your code, build your changes without interfering production data or production code. And you just saw it. We created a completely new environment in just a few seconds, which would take a lot of time and effort in other tools to set up. Now we want to work in our new environment to see what happens. So we want to modify mod users again, and let's do the same thing that we did before. We want to add the language column again. So we will open the data catalog here, and we will add the language column in the code. And of course, we need to commit the changes again so that Y42 can detect the new logic of our SQL model again. So before we switch to our data warehouse again, let's check out the space settings, because here we can view our different environments and we can select which environments should be published in our data warehouse. And we could also delete an environment if we want to. So when we now switch to the data warehouse, there will be 3 data sets, as you can see here. And our internal schema still has its 5 tables in here. And also when we check out the mod users from main, it of course doesn't have the language. But why does the mod users from our new environment has the language column even though we haven't even built this asset again?
It is because of the smart hashing system where Y42 detected that this code was already built once. So yeah, we can simply point to the old view again from our internal schema where we have the language column. And in the main, the only difference is the marked users table, but the rest is the same. So essentially with virtual data environments, we only capture the changes. We don't have to clone an entire dataset.
So let's summarize all of this. In Y42, you have the internal schema where our main branch is always pointing to. And let's say we want to create a new feature. So therefore, we create a new feature branch and we want to convert it to a new environment. How can we do that? Y42 simply creates a new dataset that points to the internal schema again so that we don't have to duplicate any data. Before Y42, you would have to create multiple datasets and always duplicate the data from one dataset to the other.